Again, notice where your A and B are. That's your first step, is to ask yourself, okay, what's my A, what's my B? We know the relationship between the three are a squared plus B squared is equal to C squared. On this problem, Sydney, what are my A and B? There you go. X and 9, it doesn't matter which is which. X squared plus 9 squared, which obviously leaves 11 for my C. So x squared plus 9 squared equals 11 squared. Now, I'll give you the option on this next part. If you want to type it straight into your calculator, before you even square anything, if you wanted to, let me show you what you can do. Take this 9 squared and move it over. You now have 11 squared minus 9 squared is equal to x squared, right? Well, why not go ahead and get rid of the square too by square rooting the whole thing? You can go ahead and clean this thing up in one step. To get x by itself, again, you're going to have to move this over. And to get rid of a square, you're going to have to square root. So you now have the square root of 11 squared minus 9 squared. Or, if you actually want to show steps, that's fine as well. Square each. X squared plus 81 equals 121. To get rid of 81, I'm going to move it over by subtracting. And again, we're trying to get x by itself. I want to know what x equals. So I now have x squared is 40. To get rid of a square, I square root. And again, we discussed the other day, normally you'd put a plus and minus there. Since you're dealing with the side of a triangle, it's never going to be negative. So you have x equals the square root of 40. You can do two things with this answer. You can leave it as an exact answer, or you can leave it as an approximate answer. This goes back to chapter 1. Let's review how to simplify this and leave it exact. X equals Jordan D. I know the square root of 4, 9, 16, 25, square root of 36, square root of 49, that's way too high. Do you see any of those perfect roots in 40? The 4. Everybody sees a 4 in there, right? So what I'm going to do, I'm going to take the square root of 40 and I'm going to break it down. And if you know what the square root of 4 is, you don't even have to write this, but the square root of 4 times the square root of 10. And again, she used 4 because she knows what it is. Mark out the square root of 4. I know that that is 2. So 2 times the square root of 10. That's exact. Or, squiggly line. I could give the approximate answer. The square root of 40 is what's called an irrational number. It goes forever. You can never write down the exact answer for the square root of 40 if you type it into your calculator. You're always going to get a rounded decimal. That's the reason we use a squiggly equals. It's about 6 point, give me one decimal, 6.3. So you can either leave your answer as exact. If you're building bridges, please leave it as exact. Or you can leave your answer as approximate. Now here's some good problems. You're given, let's see, you're looking for the value of x here. Well, we're not given, how are we going to find this? Here's your right triangle. But the problem is we're only given one side, and we're looking for another side. Ignore this over here for now. How in the world do we find this other side? Does anybody have any idea what that other side is? And why? How long is the hypotenuse of that right triangle? Brianna, what kind of triangle is that? It's an equiangular triangle. Not only is it equiangular, but it's also equilateral. Anytime you have an equiangular triangle, you also have an equilateral triangle. Well, if this is 16, and then 8 and 8 is 16, then this is 16. You didn't need that third side. So now to find x, we can do it. A squared plus b squared equals c squared. In this case, Nicole, if this is my right triangle, what's my a and b? A and B. This is my right triangle. Here's my right angle. My C is always located across from my right angle, so therefore A and B would be x and a. Good. So a squared plus b squared is equal to c squared. This is actually a special type of triangle that you'll learn about later on called a 30, 60, 90 right triangle. And that we know the relationships between all these, but anyway, we'll learn that later. X squared plus 64 is equal to 256. And again, shortcut, guys, Move 8 squared over by changing it to minus 8 squared. Get rid of the square by square rooting. You've got the square root of 16 squared minus 8 squared. Much simpler. Subtract 64, you now have x squared equals 192. To get rid of a square, we square root, so x is equal to the square root of 192. I want to simplify that. The way you simplify it, you can make a list. Again, I know the square root of 4. I know the square root of 9, 16, 25, 36, 49, 64, 81, and so on and so forth. What I would do is go through and divide 192 by those numbers. 4 will work, but there's a bigger number that'll work. Anybody found it yet? There you go, 64. We're going to take 192, we're going to split it into the square root of 64 times the square root of what? 3. And the way you do that, again, guys, there's the square root you know. Divides 192 divided by 4, 192 divided by 9, 192 divided by 16, 192 divided by 25, and so on and so forth. Use the biggest one possible. It makes it easier. And once you divide 192 by 64 and you hit enter, guess what? You get 3. So that means that 64 times 3 must give you 192. I know the square root of 64. Mark it out. Put 8 in its place. 8 root 3. Or if you want approximate, the square root of 192 is about 13 points. 1 decimal. 9. Another similar one. You're given that this is 14. We don't know what this is. We don't know what this is. We're looking for x. Well, we got tick marks. Okay, so if that's 14, then that's 14, then that's 14, and we're looking for x. We have 8 in there. Now, what shape do we have here? It's actually a parallelogram. And you're going to find out that this whole right triangle stuff, we're going to use it all year. Okay, even when we get to parallelograms. Even when we get to trapezoids, you're still using this whole right triangle stuff, so don't forget it. We're looking for, here's my hypotenuse. Here's a leg of the right triangle. Here's another leg of the right triangle. So my A and B, help me out. Cole, what's my A and B here? Always look for your right angle. That'll always be your C. Crossing the right angle C, so it'll be 14 and 14. So A squared plus B squared equals C squared. Your C, again, is always, your longest side is always located straight across from the right angle. 196 plus 196 equals C squared. Remember that step. I'll tell you why in just a second. 392 is equal to C squared. So to get rid of a square, we're going to square root. Let's go ahead and do it like that. The square root of 192. Now think. Don't use your calculator. Use common sense in this next step. I want to know what multiplies to give me 392. I want to know what I can split that into that's going to multiply to give me 392 without using my calculator. Guys, look at this. What's the square root of 196? 14, correct? 14 times 14 is 196. So what can I split what can I split 392 into? Did I not add 196 and 196 to give me 392? So does that not mean that 392 is simply, whoops, try again. 2, 192. Okay. Wouldn't that be the easiest way to do it? And I know that the square root of 196 is 14. So I know that C is equal to 14 root 2. Or if you want to approximate, that's nearly 20, isn't it? 20 times 20 is 400, so I'd say it's 19 point something. 19.8. Is that right? Awesome. Okay, here we go. You can label this shortcuts if you want to. But I like shortcuts. Pythagorean triples. There are certain problems that always appear on, for some reason, standardized tests. Don't write all that down yet. If you get on your ACT test, And you're given that you have side lengths of a right triangle that are 3 and 4. This is one of the most common problems on these tests. Yeah. If you do a squared plus b squared, a squared plus b squared equals c squared, you get 9 plus 16 is c squared, 25 is c squared, so c is the square root of 25, which is 5. This is known as a Pythagorean triple. If you have legs of 3 and 4, you'd walk funny. But if you have legs of 3 and 4, then your hypotenuse is always going to be 5. It's a common Pythagorean triple, which is the first one, 3, 4, 5. If you have legs of 5 and 12, you won't be able to even stand up. But if you have legs of 5 and 12, your third leg would be 13, 5, 12, 13. Those are the most common, the two most common Pythagorean triples. If you want to write 8, 15, 17, and 7, 24, 25 down, that's fine. And what that means to you is, if you're given a problem and 7 and 24 are the two legs, 25 is always going to be the hypotenuse. You don't even have to work it out. If 8 and 17 is a leg and a hypotenuse, you don't have to work it out. The other leg's 15. Okay, pretty much I'm giving you 4 sets of answers. Or actually, a whole lot more than that. Let me show you something, and we're kind of getting ahead of ourselves, but next chapter, we start talking about similar shapes. Okay, I've got this 3, 4, 5 right triangle. What about this? What if I make this thing twice as big? It's no longer 3, 4, and 5, is it? It's no longer 3, 4, and 5, but if I made this leg twice as big, guess what? It's now 6, it's now 8, and it's now 10. Now, is that also a Pythagorean triple? Let's test it. A squared plus b squared is equal to c squared. 100 equals c squared, so c is the square root of 100, which is 10. So what I'm trying to tell you is, not only is 3, 4, and 5 a triple, but notice what's below it. 6, 8, and 10, 9, 12, and 15, 3x, 4x, and 5x, any multiple of 3, 4, and 5. So if on this test, I give you a right triangle and I say the legs are 30 and 40. Well, that's a 3, 4, 5 right triangle, right? You see that? Any multiple of 3 and 4 would also work. What do I multiply 3 and 4 by? To get this and this, 10. So if you multiply 3 and 4 by 10, you've also got to multiply 5 by 10. So a 30, 40, and 50 would also be a 3, 4, 5 right triangle. Because of similar triangles. And that's what it's telling you below it. Don't write all this stuff down. Okay? Because what I want you to know is 3, 4, 5 right triangle and any multiple of 3, 4, and 5. 5, 12, and 13 and any multiple of 5, 12, and 13. And so on and so forth. Honestly, the other two I don't even know. I don't have those memorized. These are the two that show up most often. 8, 15, 17, and 7, 24, 25 don't show up as often. And what you can do, you can memorize those if you want to. That way, if I need help, if we run up on one, then you can just swim it. Okay, here we go. Moving on. So what does that do for us? Now when we've got problems like this, the first thing I do is I check to see do I have a triple. And here's how I do it. 12 and 15. Take that and treat it like a fraction and reduce it. Ethan, what are some numbers, or what is a number that will divide into both 12 and 15? 3. Divide it by 3. I'm going to make a note over here. I'm dividing by 3. And this turns into a 5. This turns into a 4. Is that not one of your triples? Your hypotenuse is 5. You have a leg that is 4. What's the other leg going to be? 3. 3, 4, 5 right triangle, but we divide it by 3. So instead of 4, it's 12. Instead of 5, it's 15. Instead of 3, it is 9, 12, 15. Okay, that's your 3 sides. Again, I pretty much took and I shrunk the triangle down. It's 4 and 5, so the missing leg, if it was 4 and 5, would be 3. It's not 4 and 5. It's 12, 15, which are multiples of 4 and 5. Times 3 times 3. So take your 3, multiply it by 3, and you get that missing value would be 9. Okay. Let's do another one. 48, 20. So here I've reduced that. What can I divide 4820 by? So let's shrink this thing down and see if it's a common one. Let's divide by 4. It gives me 5 and 12. That looks familiar, doesn't it? If your legs are 5 and 12, what's the hypotenuse equal to? 13. Now let's blow it back up. To shrink it down, we divide it by 4. To blow it up, let's multiply by 4. So you'll get 20, 48, and 52. Could you do Pythagorean Theorem on this problem and get the same answer? Yes. But I really don't want to do 48 squared and the square root of the huge number that's going to give you 52. It's just much easier this way. Shortcut. Plus, you think about this on your ACT, you're only given an hour to work 60 problems. That's 1 minute per problem, but some of those problems are very hard. And every second that you can save, especially on problems like this, where knowing your triples saves you so much time. Instead of spending 60 seconds on it, you could probably look at it and spend 10 seconds on it, and all of a sudden you got 50 extra seconds to spend on another problem. Again, let's shrink this down. 14 and 50, the only thing I can think of is 2 that'll divide by, and that gives me 7 and 25. Notice, the hypotenuse is 25. So, of course, I didn't have these memorized. So, destiny, we look at what we wrote down. And 7 blank 25. If the hypotenuse is 25, what goes with that? Who did I say, destiny? Did you write that one down? Did you get it, Zoe? Zoe here? No? Did anybody get it? 24. So, which did 24? So, your common triple is 7, 24, 25. Well, to go back to my other triangle, let's multiply everything by 2 again. Gives me 14, 50, and 48. Damon is locked out of his house. Been there, done that. With only one open window on the second floor. It's 12 feet above the ground. You see the drawing here. The window is 12 feet above the ground. Got a right triangle. It's a good house. He needs to borrow a ladder from the neighbor if he is going to place the ladder 5 feet. And he's got this thing figured out. These problems crack me up. He knows when he goes and borrows that ladder, I'm going to place this ladder exactly 5 feet away from the house. And again, beforehand, he knew his window was exactly 12 feet high. And he wants to know how long of a ladder he needs to borrow. We're done. Right? Look, 5, 12. What's your triple? 5, 12, 13. Finish. You see the time saver now. Now, if you didn't know that, what would we have to do? Well, it's a right triangle, so a squared plus b squared equals c squared. 25 and 144 equals c squared. So 169 equals c squared. Square root both sides. C must be 13. You can get it the other way, but why not learn your triples? That way you don't have to do all that work. Look at your answers. More than likely, this is not going to be one that we know. According to your company's safety regulations, the distance, now this is more logical. The distance from the base of the ladder to the wall, blah, blah, blah. Oh, no, we do need this. The distance from the base of the ladder to a wall that it leans against should be at least 1/4 of the ladder's length. So this needs to be at least 1/4 of the ladder's length. What's 1/4 of 20? Divide it into 4 pieces. Right. And you want one of those 4 pieces. What's 1/4 of 20? 5. What's 2/4 of 20? 10. What's 3/4 of 20? 3 of those 4s would be 15. That makes sense. 4/4 of 20 would be 20. So 1/4 of 20, we need this to be 5. So what is the maximum distance up the wall that the ladder will reach? If it's a 20-foot ladder and we need it to be 5 foot away from the wall, let's see how far it's going to reach up that. And notice your answers. And we use common sense here because I don't know, do I need the exact answer? Do I need approximate? Well, look at your answers. Those are all approximate answers, the decimal answers. A squared plus b squared is equal to c squared. Your c is always located across from the right angle. That's the longest side. 25 plus x squared equals 400. Subtract 25, you get x squared is 375. And to get rid of a square, we square root. We type in 375 into our calculator. Actually, we don't even have to. Because I know that 20 times 20 is 400, correct? So is 20.6, which is even higher than that, multiplied by 20.6, going to give me 375? No. 30 times 30, that's going to be over 900. 12 times 12 is 144. So I'd say it would be 19.4 feet. Okay. That makes sense. You don't even have to have a calculator for it. We use common sense. Moving along. Converse. Nearly finished. Got 8 more slides. The converse of the Pythagorean theorem. Again, converse. That means we flip-flop our P and Q statement. And instead of if P implies if P then Q, we have if Q then P. The Pythagorean theorem states that if you have a right triangle, then a squared plus b squared equals c squared. The converse of that would state if a squared plus b squared equals c squared, then you have a right triangle. Let me tell you a story about this, which right there is all that you need. If a squared plus b squared equals c squared, then the triangle is a right triangle. Previous school, we were going to actually build a greenhouse, just like what we have here. We were in the process of building a greenhouse, and they needed my help. And the reason they needed our help is they needed to lay a foundation. They needed to get the foundation ready, and you really don't want a parallelogram for a foundation. If you're going to build something, if you're going to build a house, you really want right angles here, correct? I'll show you a trick, and this is not the only way that you can do this. There's actually probably a better way. They show you a trick as to, okay, you're ready to lay a foundation. You want to make sure that these 4 angles are right angles. Here's a way to do it. Take a tape measure. And what I would do is, and what we did, we put a stake here, and we strung a line. So this is already here. And what we did was I took a tape measure, and I measured it's probably 6 feet. 1, 2, 3, 4, 5, 6 feet there. And I need to put a stub somewhere over here attached to a string and make sure that it is a right angle here. So imagine this as being a loose stub. I don't know where to put it. So what I did, I measured 8 feet. 1, 2, 3, 4, 5, 6, 7. I measured 8 feet out, and I actually put a mark on my string there. And I want to place this green stub somewhere to where, I mean, if you place it down here somewhere, that's obviously not a right triangle. That's an obtuse angle. If I place it up here, obviously that's going to be an acute angle. So I need it to where it's going to be exactly a right triangle. So I've got this thing marked at 6. I've got the line here marked at 8. You know how I can ensure that that's going to be a right angle? Measure the distance between the 6-foot mark and the 8-foot mark. And I didn't have to use 6 and 8. I could use the other numbers, and I'll ask you in a second what numbers those could be. So if we got the 6-foot mark, we got 8-foot mark, the distance from here to here, in order to ensure that this is a right angle, needs to be what? 10. My question for you, what if it's bigger than 10? Is this going to be a right angle? No. What kind of angle would it be? Obtuse. What if it was smaller than 10? Would that be a right angle? No. It would be an acute angle. So do you see how you could actually ensure that you had a right angle here? Now that you've got this stop mark, then you'd have to do it again and make sure this is a right angle. But once you have that, and that a right angle, your fourth one's pretty much guaranteed. But you can do that 3 times, and all of a sudden you have a good foundation. You have a good rectangular foundation. And what you just did was actually told me the other 2 theorems that go along with this. Pythagorean inequality theorems. What if the c value is bigger? Need to write these down. If c squared is smaller than a squared plus b squared, then you have an acute triangle. If c squared is bigger than a squared plus b squared, then you have an obtuse triangle. Here's the way I want you to remember this. If a squared plus b squared is equal to c squared, you have a right triangle. where this is my C. Very important. Know that your C is your hypotenuse. It's always across in the right angle. Now, here's what I want you to do. Imagine taking C and making it smaller. To where no longer is a squared plus b squared equals c squared, but now C is smaller. So when you work it out, you've got a squared plus b squared here. You've got c squared over here. You work it out and you find out the c stuff is smaller. Make c smaller. Take this and shift it in. That's not a right triangle anymore. That's not a right angle anymore. It's now an acute angle. So if C is smaller, you have an acute triangle. And the other scenario, take C and make it bigger. So again, you work it out. You do a squared plus b squared, and you do c squared, and you find out that the c stuff is bigger. So make C a little bit bigger and see what happens. This is no longer a right triangle or an acute angle. It is now an obtuse angle. So if your C stuff is bigger, it's obtuse. If your C stuff is smaller, it's an acute angle. If your C stuff is equal to your a squared plus b squared stuff, it is a right triangle. There is a relationship amongst angles and sides of a triangle. And you see we're going one step closer. We're trying to discover that relationship. First problem. Determine whether this can be a triangle. We're going into old stuff. Is this a triangle? And if it is a triangle, is it an acute triangle, a right triangle, or an obtuse triangle? There is a relationship between the sides and the angles of a triangle. Let's go back and review. Can this be a triangle? You remember doing this? If this is 16, this is 7, and this is 14. We close this trying to form a triangle. Will it hit? Will the sides hit before it hits this bottom? Yes. That is a triangle. Now, whether it's going to be a right, acute, or obtuse really depends on how quickly it's going to hit. So let's see what kind of triangle we have here. Here's how you test this. I need you to do a squared plus b squared, and I need you to do c squared. I'll give you a second to do that on your own. Here we go. So again, make sure that we know here's a and b. C is always the longest. A squared plus b squared. Kaylin, what'd you get for that? 7 squared plus 14 squared gives you... Yep. Stephen. Did you get it, Stephen? 7 squared plus 14 squared? 49. Now 12 squared is 144. That's 196, which gives me a total of 145. Anybody else get that? Okay. And 245. Thank you very much. Trick question. There you go. 245. Told you. And Jordan P., did you get c squared is 16 squared? Have you got that yet? 256. So the first thing I noticed, these are not equal. If a squared plus b squared is equal to c squared, this is a right triangle. This is not a right triangle. C's bigger. And think about the scenario I told you a while ago. If a squared plus b squared is equal to c squared, you have a right triangle. Make C bigger. In this case, C is bigger. And Kyle, if I took and I stretched C out and made it longer, I'm not going to have a right triangle, but I'm going to have a what type triangle? Obtuse. So this is an obtuse triangle. Any questions? Next problem, 9, 40, and 41. And again, to work this, we are going to do a squared plus b squared, and we're going to do c squared. Somebody's got your calculator handy there. AB is 9 and 40, and I know that C is 41 because it's the biggest. Destiny, do you have your calculator? Type in 9 squared plus 40 squared for me. 9 squared plus 40 squared. It'd be 81 plus 1600, I think. There we go. We could have done that in our head, couldn't we? 1600 plus 81 would be 1681. Good. And Vanessa, not here. Claudia, type in 41 squared for me, please. A squared plus B squared is equal to C squared. So therefore, this must be a right triangle. Don't have to, but guess what? You have a new triple. That's not one that we listed, but if you want to list 9, 40, 41 on your triple page, again, it's not one that occurs very often, but it is a triple. If 9 and 40 are the two legs, then the hypotenuse will be 41. If 9 and 41 is a leg and a hypotenuse, the other leg has to be 40. That is a Pythagorean triple. Moving on. Uh-oh. This is tough. 2 root 3, 4 root 2, and 3 root 5 are the three legs. And I'm asked for what kind of triangle is this? I want to pay close attention. Let me come down here and actually do this for you first. 3 root 7. If that was a side of a triangle, I've got to square this. I've got to somehow square this. Let me show you how to do it. Let's go back and revisit some algebra real quick. If I asked you to square 3x, how do you do that? Can anybody tell me what is 3x all raised to the second power? There's two pieces in there. Square 3, square x. Easy. All right, you'll handle that. Now, I do want to caution you on something. Let's go back and again review a little bit of algebra. These two things are being multiplied and they're squared. But what if they were being added and you were asked to square it? Do you do x squared plus 9? No. Okay, there's a difference there. And this has absolutely nothing to do with what we're doing now. I just want to remind you for future instances. If two things are being multiplied together and you're asked to square them, square each one. Okay, square the 3, square the x, done. How do I square x plus 3? Remember this? You pull it out. You have to pull it out. To square x plus 3, you got to do x times x times 3, 3 times x, 3 times 3. Multiply each of these times each of these. There's 4 different things to multiply. You multiply the first, x times x. Multiply the outside, x times 3. Multiply the inside, 3 times x. Multiply the last, 3 times 3. That's when you have a plus or minus sign. But what we're doing looks like this. You might have to square 4xy. How do you square that? Well, you square the 4, you square the x, and you square the y. And that's what we're doing here. How would we square 3 root 7? It's easy. Okay. You square the 3, that's 3 times root 7, just like this. You square the 3, which is 9, and you square the square root of 7. How in the world do you square the square root of 7? You multiply times itself. How do you square the square root of 7? What is the square root of 7 times the square root of 7? The square root of 49, which is, what's the square root of 6 times the square root of 6? The square root of 36, which is 6. What's the square root of 8 times the square root of 8? Square root of 64, which is 8. So, we see a shortcut. If I want to do the square root of 3 squared, I do the square root of 3 times square root of 3, which is square root of 9, which is 3. If I do the square root of 4 squared, that's square root of 4 times square root of 4, which is square root of 16, which is 4. Why does it work like that? Take a number, any number. Let's try 10. Add 3 to that number. Got it? Now take 3 away from that number. Got it? What do you get? 10. Take any number. Multiply it by itself. Got it? Now take the square root of that number. Got the answer? I bet you get what you started with, right? Squaring and square rooting undo each other. If you take the square root of something, let's do it like this. Take the square root of 9 and then square it. What do you get? 9. So do you see what we're doing here? The square root of 7 squared is 7. To make a long story short, a square root and a square cancels each other out. So this would be 3 to the second power, the square root of 7 to the second power, which would be 9 and 7, or 63. I'll do one more of those for you. 4 root 3 squared. Now they're easy. I've got to square each of these. 4 to the second power is 16. The square root of 3 to the second power is 3. Try it again. 3. 16 times 3 is 48. Now we're ready for the problem. I'm assuming, and I'm hoping I'm right, that they're in order, A, B, C. I'll find out in a second if I'm wrong. Now, how can I actually know? What's this? These are all decimal numbers. If you want to know which one's bigger, type in 2 times the square root of 3. Type in 4 times the square root of 2. And type in 3 times the square root of 5. Now, why did I have to do that? I need to know which one's bigger. C is always the biggest, and it looks like to me 3 root 5 is 6.7. It's the biggest. So therefore, I'm good, A, B, and C. Now, I need to do A squared plus B squared, and I need to come over here and do C squared. A squared is 2 root 3 squared. B squared is 4 root 2 squared. C squared is 3, bless you, root 5 squared. Now let's try this. A squared plus B squared. Square each. 2 squared is 4. The square root of 3 squared, once again, is what? Square root of 9, right? Which is 3. Or a square and a square root, just get rid of the square root. 4 times 3 is 12. Plus, 4 squared is 16. The square root of 2 squared simply gets rid of the square root. It's 2. 16 times 2 is 32. 12 and 32, you get 44. And I don't think that one over there is going to equal 44. Chris, help me with this one. Square each of them. What's 3 to the second power, Chris? 9. Perfect. And the square root of 5, use my shortcut. The square root of 5 to the second power is? Perfect. Everybody good with that? Which is 45. Those are really close. If you drew this with these side lengths, if you were given 3 sticks and said make a triangle out of these 3 sticks, it would look like a right triangle. Why? Because A squared plus B squared is so awfully close to C squared. This would look like a right triangle, but it's not. C, the C side is slightly larger. If A squared plus B squared equals C squared, then you have a right triangle. If I make C slightly bigger, Carson, what kind of triangle would it be? If I make C slightly smaller, it would be a cube. Nearly finished. Make sure about, be careful about getting gung-ho about these problems. And say, okay, I've got to do A squared plus B squared, I've got to do C squared. A lot of people are going to do that. Let's see what happens if I do. A squared plus B squared, C squared. And I do, somebody's got a calculator, A and B are 6.2 and 13.8. And I want you to type in for me 6.2 squared plus 13.8 squared and see what you get as an answer. 36, 196, 2, right around 220, 230, somewhere around in there. To what? 228.88. And you're going to come over here and you're going to do C squared is 400. Right? And you're going to say, oh, since C is bigger, this is an obtuse triangle. And you're going to put obtuse on your test. And what am I going to put on your test? A big red X. I'm going to mark it right. And you're going to say, but you just told us. If C is bigger than A squared plus B squared, it's an obtuse triangle. Read the first line. Determine whether each set of numbers can be the measures of the sides of a triangle. This triangle is going to be extremely obtuse. for this reason. If this is 20, and this is 6.2, and this is 13.8, explain to me what's going to happen when you fold that and try to make a triangle. They're going to hit on that line, aren't they? If you add 6.2 and 13.8, guess what you get? 20. So as you fold this in, it's going to fold in all the way, and you see now why I told you it's going to be extremely obtuse? Because what's that top angle going to equal? 180 degrees. Okay? This will not form a triangle. Now what if I made this 13.9? Would that be a triangle? Yes. And what kind of triangle would it be? Without even working out, it's going to be very obtuse. Because that's just going to barely hit before, and you're going to have like a 160 degree angle at the top. Now, how can I figure out how big the angle is going to be? That's where we're heading. Okay? It's where we're going. Two more problems. Determine whether this triangle is acute, right, or obtuse given these vertices. Guess what? You got to graph it. You're given the points -7, -3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. The point -2, -5. 1, 2, 3, 4, 5. And the point -4, 1, 2, 3, 4, -1. Now, could you just graph these and look and see what you think is true? Well, possibly. But I don't know. This is pretty close. I don't know if you can just tell by looking. We have to try to tell whether it's acute, obtuse, or right. By looking at it, it looks cute, doesn't it? But I have no idea. If I were given the 3 side lengths, isn't that the problem we just worked? You were given 3 side lengths, and that's fine. If I'm given the 3 side lengths, I can do a squared plus b squared and c squared and find out exactly what it is. Well, I've got the 3 side lengths. Look. Gives us extra practice, too. I need the length of the 3 sides of this triangle. The way that I'm going to find that, instead of using the distance formula, I'm going to use Pythagorean Theorem. 2 and 3. 2 and 1, 2, 3, 4. And 2 and 1, 2, 3, 4, 5. To find our first leg, we'll do this one first. Let's do it in our head. A squared plus b squared is equal to c squared. Your a and b are 2 and 3. Rachel. 2 and 3 is my a and b. Do a squared plus b squared for me, please. A squared is, a is 2, so a squared is, and b squared is, a squared plus b squared, therefore would be 4 plus 9, or 13. That's equal to c squared. You've got to be careful. The distance is c, so I have c squared is 13, so the distance would be the square root of 13. Leave it as the square root of something. It makes your life so much easier. So that is the square root of 13. The distance of my second one, Jackie, help me with it. A squared, a is 2, b is 4. Do a squared plus b squared for me, please, Jackie. 2 squared plus 4 squared. And you get 20. So 20 equals c squared, so c must be the square root of 20. And on the last side, Erica, I have side lengths of 2 and 5. Do a squared plus b squared for me, please. A is 2, b is 5, a squared plus b squared, which gives me 29. So 29 is c squared, so c must be the square root of 29. Now let me show you why I left them as square roots. I've got to do a squared plus b squared. I've got to see what kind this is. And I've got to do c squared to see what kind of triangle the green triangle is. A and b are root 13 and the square root of 20. C is the square root of 29. Does anybody see why I left them the square roots now? The square root of 13 squared. You can do it the long way or you can do it the short way. Take the square root of 16 and square it. Take the square root of 25 and then square it. Take the square root of 36 and then square it. What is the square root of 13 squared? Anybody? Thank you. What's the square root of 20 squared? What's the square root of 29 squared? So 13 and 20, that's 33. This is bigger. C is smaller. You see that now? Take a right triangle, make C smaller, and all of a sudden you now have what kind of triangle? Good. That's an acute triangle. So what you got to do on these problems, if you're given 3 points, you have to find the length of the 3 sides, and then compare it using a squared plus b squared and c squared. Last problem. And it's a doozy. Is it possible to carry a 9-foot piece of lumber in an enclosed rectangular trailer that is 4 feet by 8 feet by 4 feet? We'll call it 4 feet by 8 feet. Let's put the 8 down there. 4 feet by 8 feet by 4 feet, and I want to carry a 9-foot piece of lumber in there. This one might be hard to see. Guys, when you put something in a box, if you have a rectangular prism box and you want to put a baseball bat in it, I bet when you put it in, you're going to prop it down into a corner and it's going to go catty corner kind of. That makes sense? So what I need to do is and this, like I said, these are pretty advanced problems here. I need to see how big of a catty corner do I have. What is the distance from here up to here? Now, how in the world am I going to find that? Remember that this is a box. It is a 4 by 8 by 4 box. It doesn't really matter where you put the numbers and stuff. But what I'm going to do first is I'm going to find the distance from here. Let me do it in red. I'm going to find the distance from here to here. That's not where you're going to put the baseball bat. That's not where you're going to put the piece of lumber. That's saying if it lay completely in the bottom. It's not going to. Okay, I really don't think that you're going to be able to lay the piece of lumber in the bottom of it. But let's see how far is it from here to here. The way that you do that, well, this is a triangle. This is a right triangle. You're going to do 4 squared plus 8 squared equals, I'll call it x squared. And that's going to tell me how far it is from B to A. Some of you might be seeing where we're going with this. 16 plus 64 is x squared. 80 is x squared. X is the square root of 80. I'm going to split that into the square root of 16 times the square root of 5, which is 4 root 5. So I can now erase my x and put the distance from here to here is 4 root 5. That tells me absolutely nothing. I don't know what 4 root 5 is. Somebody take their calculator, type in the square root of 80 for me, please. 8 point what? 8.9. Okay, think about it. I'm putting a 9-foot piece of lumber in this box. It is 8.9 feet. The bottom of the box from one corner to the other corner is 8.9 feet. It'll nearly lay flat. Y'all see that? That piece of lumber would nearly lay from here to here. You only need 0.1 feet. So my question for you is it going to fit? Yeah. I want to see, though, how much room I'm going to actually have. It is 4 root 5, or 8.9 feet from here to here. But I want to know how far it is from here up to here. Well, how in the world do I find that? You have a new right triangle. That's it. And I want to know what the hypotenuse is of this right triangle. Well, how far is it from A to D? You may know that. Unless it's a funny-looking box, it's 4 feet. The same as this. The height's going to be the same regardless of what corner you're talking about. So in order to find the distance from the bottom corner to a top corner in a box, you have to do the Pythagorean Theorem twice. Okay, this is 3D imaging. So let's go back, and I'm going to erase all my previous work. I found out that the distance from here to here was 4 root 5. I know the distance from here to here is 4, so I want to know how much distance I'm going to have to put something catty corner in this box. The way that you do that, you do a leg squared 4 root 5 squared plus the other leg squared is equal to, I can call it C now. C is the distance, catty-corner distance there. To square this, it's going to be 16 times 5 plus 16 equals C squared. That's going to be 80, and 16 is 96 equals C squared. So C is going to be root 96, which again, if I simplify that, it means 0 to me. It'd be 4 times 24 is 16. That's like 14. 16 times 6. That'd be 4 root 6. 4 root 6 mean anything to you? Nothing, right? If I tell you the distance from B to D is 4 root 6, it means nothing. Give it to me as a decimal. The square root of 96 is about 9 7. So C has a distance of about 9.7 feet. So the question is, can you put a 9-foot piece of lumber here to here? Yeah, you got 9.7 feet. So your lumber would actually, you had 8.9 feet here. So your lumber would lie kind of there, if I had my guess. But it will fit.